Hey there, welcome back to the channel. My name is Chris, and today we're live streaming a video on building the YoshiStat. Basically, we're building up a thermostat using Raspberry Pi and C#, and today I am going to start the grunt work of building up the software stack that will run on the thermostat itself. So with that, let's go get started. Here are the features that we originally did last week, but let's go ahead and open up Visual Studio, and I'll show you the general, I guess, outline of how I start any project like this. Okay, so the first thing I tend to do is I always start with a blank solution. So I'm going to do this, and if we go take a look at what it created, you'll see it created it here, which is not where I want it. Close the solution. I'm going to create a folder called source, and I'm going to take just the solution file, put it here. So in this source folder, I'll have the solution, and then there will be folders in here for each of the projects in the solution. All right, we now have our empty solution. When I build something like this, there are going to be a few things to consider. Number one, I don't want to develop right on the device until I absolutely have to. It's faster to develop on the desktop, so I want a desktop project as well. So I know I'm going to need a desktop project. We are going to be targeting hardware that is the YoshiPi. So this is going to be the final hardware that we use. But until that time, I really want to work on the desktop for doing UI iteration, things like that. So I want desktop and a YoshiPi project. Now, because we have two different platforms, that obviously means that I'm going to have some common stuff. So I'll have a core project that has shared things between the two. So I'm just going to start out by creating the core project. And this is just going to be a class library. Just to be forward looking, I'm going to make this core project a .NET Standard 2.1. So we'll call this YoshiStat Core. I'm going to change this to Net Standard 2.1. One of the first things I want to do is I'm going to change the way the namespace is. It already doesn't like that because the language is wrong. So I'm going to come in and change our language version to the latest. Now the desktop is just going to be a console app, and I'm going to make that .NET 8. All right, let me make this a little bigger. So if we take a look here, what it's building, you can see we have our solution in the source folder, and then it's creating these subfolders for us. So we've got core and desktop. Now we want the actual hardware version. Here, we're going to select an IoT application for YoshiPi. There's a template for this. I'll put a link down below, but you can get it just in Visual Studio. If you go do search for templates and search for YoshiPi or even IoT, it comes up. So I'm going to select this. I'll call this YoshiStat.YoshiPi. Typically, when I'm building things like this, I'll give it project name and then target hardware. So if I was doing one for the Meadow F7, I would probably call this F7. Okay, so we've got our three projects. Now, this one is going to reference core. This one is going to reference core. Now we have to do the grunt work of getting all of our dependencies in. We're going to start by using NuGet packages and see how that works out for us. You can see over here the YoshiPi one, we already have a reference to the YoshiPi NuGet package, and then that brings in a bunch of Meadow stuff. So the desktop, let's go here, and we're going to add a reference to Meadow Desktop. Now in core, almost certainly we're going to need to add some other references. So let's at least pull in Meadow contracts so that way we get all of the interfaces. We may end up, moving up stack and pulling in something like Meadow Foundation, but we'll worry about that when we cross that bridge. All right, so we have our three projects. We've got core, which references Meadow contracts. Then we have our platform targets, desktop, which references Meadow Desktop, and the YoshiPi project, which references the Yoshi Maker YoshiPi NuGet project. So now we're all set up as far as our solution goes. And this is where we turn to doing a bunch of the, I guess, housekeeping, building up folders, building up interfaces, things like that that we know we're going to need. When I'm working on a project like this, really any start of a project, I like to generate folders and some interfaces and things like that for the large blocks of work that I know the app is going to do. And generally I start down in core. So I'll create things in core, create interfaces for them, or classes for them. Depends on, the functionality. And then I can promote those to instances in each of the platforms. That'll make sense here as we go along. So the first thing I'm going to do is I'm going to create some folders in here. And I wish Visual Studio had an easy way to increase the font size on this. If the font size on this is problematic, go ahead and leave a comment down below and I'll work at trying to figure out something a little bit better in the future, or maybe I can, in editing, I can zoom in on this. But I'm going to create a few more folders. Okay, so now the next thing we want to look at is what I call services. Services are effectively functional blocks for the application. I like to break everything down into functional blocks that are very discrete, and we'll have a class for each one of those functional blocks. An example here is we know that we're going to be driving a thermostat, so we have relays that we need to turn on and off for driving the air conditioning if you have it, driving heat if you have it. Those I consider outputs. So what I'm going to do is I'm going to create an output service. Now I know that the output service is going to be different between what I'm running on the desktop, where I'm going to want to just simulate the outputs, and what is going to be running on the YoshiPi. So that obviously means that we need an interface. So we could go in here and we could say add class, etc., etc. But I'm lazy. I love to just do this. So I'll create the interface right here in another class that is in the solution. And then I'm going to create a sensor service and an input service. Now, you might ask, what's the difference between the sensor service and input service? You could push these together into a single one if you wanted. I conceptually view them differently. Sensors are things that are, well, sensing. They're bringing in environmental variables, telemetry. In this case, we're going to have a temperature sensor. We might have some other things, but that's the obvious one. The input service, I consider inputs from a person, right? An operator. So HID, human interface device. I kind of look at them as separate because they're going to be controlled differently logically. So the sensor service, we're going to have our temperature sensor, and then our input service, we're going to have the touch screen or buttons or whatever it is that the user uses to interact with this device. So conceptually what we know is we're reading the sensor service, and then we're turning on and off relays based on inputs from the user. So we actually have some aggregating thing, right? That is going to be the master controller of how all of this works. It's kind of the service that will incorporate all of the logic of the thermostat itself. Now, the logic for that is all going to be in core. We're not going to have different logic for the desktop and different logic. We're not going to have different logic between the desktop and, say, the YoshiPi. The way it operates should be the same based on whatever the inputs and whatever the outputs are, things like that. So that means that this probably does not need an interface. This can just be a class. I'm going to call this I don't know, we can call this the main controller. You can come up with whatever name you want. We're going to start with this thing being internal because I don't think anything else outside of it will need it, though we might have to have some sort of a public interface so that the applications can create the instance. We'll figure that out here in a little bit as we run into it. Let's call it the main controller. It's the thing that is going to be basically the control logic loop that handles everything. It's going to tie all of the services that we create together. So we've got services that have distinct functionality. Then we have this main controller that does all of the interactions between them. Generally speaking, none of these services will know about or interact with one another. They will all be done through this main controller, which will do the aggregation. Now, I know that we're going to have, so the output service we're going to have, we have heat and cooling. Now, there is heat, cool, and fan. You might have multiple stages. We're not going to try to control all of that. And we know that the YoshiPi has 2 relay outputs, right? So we only have the option to set 2. So we're going to have, we'll start with just voids. We can, again, change these to tasks as we move forward, but conceptually, I know we want to be able to turn on heat, and we want to be able to turn on the cooling. We want to be able to get the temperature. Now, it's arguable whether or not we want to do this as a property or as a method or even as an event. So for right now, again, we're just building up our interfaces based on what we think the application will do. These are going to morph over time. I'm not going to sit down and write out a spec and hammer all of that out. There's no need. For most of this stuff, I like to let it just grow organically as I go through the thought process of what is the functionality of the overall device. So let's just start here with a temperature. Again, we want to use temperature because I don't like ununitized things. If we had something that said, let's say 28, right? Is 28 a temperature? First of all, is it even a temperature? But second, is it a temperature in Celsius? Is it a temperature in Fahrenheit? If you have a temperature unit object, there are no questions on what the number is and what its units are. And it provides easy conversion between the two. This thermostat, it would be nice if we could display both Celsius or Fahrenheit, depending on the user's preferences. So, in fact, that might be something that we want to update here, which actually gets me to another service. Let's finish this and then we'll come back to that service. It just occurred to me that we need. So let's go with a temperature. And for now, let's start with a property. And let's call it the current temperature because we're going to be dealing with temperatures that we want to drive to, target temperatures. There are a bunch of other temperatures that may occur in this. We could get really complex and actually put a sensor inside a vent and find out what the temperature of the output of our HVAC is. So let's at least be a little more granular than calling it just temperature. The other service I just thought about, we have a display service. The display service will control the output to what the user sees. On the YoshiPi, it's going to be this display here. But on the desktop, we're going to have a simulated display that is just a window on the desktop. So that's why we're going to use an interface. We want to update current temperature. So we want to be able to show the temperature. There are some other things that we're going to want to be able to do, right? Public update control state. And what is the control state? So we're going to have an enumeration, and let's just call it control state. The control state is the state that we are currently setting the HVAC unit too. So it's going to be, I guess, idle, disabled, off, some, terminology like that. I'm going to call it idle. Or we might be in a heating state, or we might be in a cooling state. There may be some other states, depends on the complexity of our logic, but right now that we pretty much know what that is. And so we're going to take that and we're going to do the current state here. Now, the reason we'd want to do this for the display service is we want to put an icon on the screen that says, I'm not doing anything, I'm heating or I'm cooling, right? You put a little flame icon or a snowflake icon or just clear all of those icons for our control state. So we want to be able to show the control state. We want to show the current temperature. Now, another thing that we want to be able to display is not just what is the current temperature, but what is our target temperature? What temperature are we trying to achieve? From a controls perspective, that is going to be called a set point. It is the point that we are trying to get to. There are some other things that we have to be aware of in this, like the dead band. That is something that probably the main controller will deal with. So we're not going to worry about the dead band, but we do want to be able to display the temperature that we're trying to achieve. We might not always display it, but maybe the user can push a button and see it, something along those lines. I'll worry about how that all happens once we get some design framework back from Jorge. But what we have here, these variables and things like that, I think are going to inform him on what he wants to display. We'll also get some design work back from him, and that will update this. I think he wants to show maybe some current weather. So if we're connected to the network, we might want to be able to go out to Open Weather Service and put like clouds, sun, things like that. Tell us what the current maybe outside temperature is, what the weather conditions are. We might want to, we had talked about doing, I think it's on this list somewhere here. Yeah, a history chart. So we're going to have a bunch of that. Right now, that is really, really nebulous on how that's going to work and how it's going to get displayed. So we're not going to worry too much about it. So for now, let's just put in the set point. And that is, again, going to be a temperature. For now, that's good enough. We want to be able to show the current temperature, show our control state, and show what our set point is. And in fact, as we build this logic up, just displaying those three on the screen will help us to debug and make sure everything is working the way we want. Now, the input service, if it was button controlled, what would you do? You would have a select button, maybe an increment and a decrement. We would have similar from a touch screen. You're still going to have a virtual button on it. We will do buttons, whether they're physical or virtual. So we want, let's say, increment, decrement, and select. Maybe if this is menu driven, we also might have a back. So let's back or cancel, something along those lines. At any rate, let's just do those. Now the input service, this is going to be the user clicks on something. So this is really going to be event based, right? So on increment requested, and really we don't need to pass anything else. So we have an increment, then we'll have decrement, accept and cancel. So as I had said, I tend to just build these all into some class here. And so now I'm going to use Visual Studio. Control period brings up, I guess, these quick actions. And then the first one here is move to control state CS. I do this often enough, it's just muscle memory. I don't even look at the menus. So I'll just go control period enter. And you can see over here, it moved it into its own file. And then I'm going to take that and I'm going to move that up into, let's actually create a new folder for constants. Now I can take that control state enum, move it up into constants. Now here, I've got the main controller and class 1. I know I'm never going to need class 1. I'm just going to delete that. And then this main controller, I can hit control period again, and I can just rename the file from here. So now the file has already been renamed. I'll take all these interfaces, drag them up into our interfaces. So now we have at least a good start for our interfaces. Now you can see I've got a services folder as well. Why do I have interfaces where I have these I services and then a services? The reason is you may have a core service that all of the apps use. So we can end up putting some actual concrete classes in here. So we're going to do main controller run. This run is never going to get exited. We're going to start up the main controller, and it's just going to basically probably have a while true loop. And there will probably be a state machine, something like that, that it just continually looks at the state of everything and adjusts, turning on and off the heat, updating the display, doing things like that. The next thing we want to look at is an implementation. Again, we know that the actual hardware is going to be this, but again, I really like to avoid going to hardware until, I absolutely have to. It's kind of like a last mile thing. I'm going to develop as much on the desktop as I can because I can iterate quickly. Before I get there, though, the one other thing that we have is we have this, the idea of the overall hardware, right? There's some encapsulation of the hardware has a display, it has a touch screen, it has buttons, it has things like that. So I want to define a common interface for all of the hardware that is going to be part of the thermostat itself. So let's go take a look at that. So I'm going to call it the YoshiStat hardware interface. I know it's going to have an pixel display. That is our hardware. So this physical display here, or the window on the desktop one. So we'll have a display. We'll have a touch screen. So this is our entire hardware definition. Again, we're just building out conceptually a rough skeleton or a scaffold of what it is that we think is going to appear in the final solution. This will almost certainly change, but this is a good place to start. So I'm going to move that over to an interface as well. All right, so now let's go over to the desktop. And let's add a couple of folders here. And I'm just going to kind of mirror what I have above. I have services, and I have entities. So in this desktop app, I guess the first thing we can do is we can actually turn this into a Meadow app. So program will be of type app desktop. Now, that's causing us problems right there. Now, in main, we have to change this to an async task. And now we're going to await Meadow OS start. And we can pass the args. This is the key here on a desktop to getting the Meadow OS stack for the application to start. Sometimes I'll put this in its own, like into program, and then create a different app. Meadow OS start will actually find this class through reflection because it knows it is of type app and it will start it. In fact, let's just do that. We'll keep this main in its own class. We have, if you're familiar with Meadow applications, we have our initialize, and run methods. In our initialize, we're going to create services, any concrete instances of sensors, etc. And then here, in fact, we can just do this right now. We can create our new main controller, and then down here, we're going to call run. Remember, run on that main controller is likely to never return. And right now, it returns a void. It may end up being an async with a task. That is all to be determined. The next thing we want to do is create some implementations of our services. I like to get quick wins, be able to see things progressing. So I'm going to start with the display service, and we're just going to, put up a hello or something along those lines. Basically, can we put some text onto the display? Again, we're just working with the desktop here. We don't need to worry about the hardware quite yet. Now, the display service, we know that it's going to obviously write out to a display. So we need a pixel display. Remember that interface for the hardware. We need that display to come in. We could actually just pass in the entire YoshiStat hardware, but the downside to that is if we pass in the entire hardware, then this class has access to things beyond the display, and then you become tempted to go, oh, well, I could just, use the buttons right in here. I want to completely avoid that. So I'm going to pass in just an pixel display. For the display, I'm going to want to use micro layout for laying out the controls that show up on screen. Now, already I'm starting to think that I've made a mistake, right? Because if I have a pixel display, which is an interface that comes in, and I'm going to build it up with micro layout, so I simply have labels, buttons. All of these things are not specific to the desktop. So in fact, this display service can probably move out of the desktop project and move down into the core project. So I'm going to hit save to make sure that those changes are there. And I'm just going to take this service and bring it up and drop it into the core services, then come back to the desktop and remove it. So now I've got the display service here in core. Now the first thing we need is not just a pixel display. We're going to create a screen from this. And in order to have that, we're going to have to add another dependency on micro layout. So we have our display screen and we pass in the physical display. And we know that we're not going to have any rotation or things like that. So for right now, we're just going to pass in this display. Not going to worry about themes, any of that. The next thing we have to do is we need to create all of the controls that build up the screen. If you're familiar with old school WinForms, you usually know that you can go into an editor, build up your thing, and it builds all of the code behind. So this is effectively the code behind. I call it create layouts. If it gets really large, we can split it into a separate file and make it a partial class, just so that it's easier to manage from a perspective of, viewing code. But for right now, we're just going to do this. If you're familiar with things like WPF or Xamarin Forms, you know that you've got layouts that can contain controls. So what we're going to have, at least in my mind right now, is a layout per screen. I believe we're going to have, just the default screen that we see normally, and then we might be able to move to a settings screen. We might be able to go to a history screen, things like that. So I will have a different layout for each one of those. I'm going to use an absolute layout for our home. and it's a new absolute layout, and it's going to be the full screen. And then let's just start with a button, or not a button, but a label, big label in the center for our current temperature. So now positioning, I'm not going to worry about until we get some feedback from design. I'm just going to put it at the top and then I'm going to center it. But what I'll do is I'm going to make it a 0, 0. And in fact, let's give it at least a little bit of a margin. The home layout width -10 because I have a 5 pixel margin on the left. I want one on the right. And let's just go with the largest font that I think we have. Now we're going to take this label and put it into the home layout. And then we're going to take the layout and put it on the screen. Let's just start with something like that. All right, so we have our layout, basically a home layout with a single label that has some text in it. Now let's move upstream from this. We need to create this display service. So where does that happen? Well, we have this YoshiStat hardware interface. So let's create an implementation of this for the desktop. Because I am lazy, I'm just going to put it right in here. Desktop hardware that implements that interface. I'm going to move it to another file, push it up into the entities folder, implement this interface. So now we need the pixel display filled out in this. And we could pass it in, or we could go get it from the desktop here. So we have a display and a touch screen. On the desktop, the touch screen is simulated with, the mouse clicks. So let's just do this. I'm going to resize it because 240 by 320 or 320 by 240, whichever it is, on the device looks fine, right? But if we go with that same size on the desktop, it's going to be really small and it's going to be less useful, especially if you have a high-res monitor. So I want to make sure that it is 320 wide and 240 high, but I'm going to set the scale to, let's triple all pixels. So now a pixel will become 3 by 3. It's saying that it's not certain that this exists, right? It's unnullable, I guess, like that. But we can get rid of this warning. This should never happen, but we want to get rid of the warning. And our touch screen, no, touch screen is desktop display as I touch screen. Now I'm just basically casting this display to a touch screen because I know that the desktop screen is clickable and therefore implements iTouchscreen. All right, so we have this desktop hardware that has both a display and a touch screen. So now we have to, again, move up stack and we need to build this. And it wants the desktop, and device here is a desktop instance. So now we have our hardware created. And now what we can do is when we create our main controller, we can pass it in the desktop hardware. Let's go over to the main controller. So this should get us our initial, bring up. So let's look at this as a desktop app. Desktop app enters, calls Meadow OS start. That's going to find and instantiate this YoshiStat app because it is type app. Then it's going to call initialize. It's going to have populated the desktop into a device property. So initialize will create the hardware, which will create desktop hardware passing in this device. So now we have hardware, which creates our display. Now, then that creates the main controller. The thing that we need, though, is we need that service, right? Our display service. So our main controller. Let's start with a initialize, and this will create services. Now this takes in a display, right? So let's do the hardware display. So this is going to pass in this case, because this is desktop hardware, it's going to pass in that desktop display. And then in run, we're going to call initialize. So in theory, I think this will work. Okay, so now let's just run this and let's just step through what it's going to be doing. So we know it's going to step in here, but then it's going to use reflection to get here. So we know it's there. I'm going to clear that. Now it's going to call in here. So into the desktop hardware. We know the display exists. It's going to resize the display and then store it. And you can see touchscreen is a thing. So that cast that I did is valid. Now we're going to go into our main controller. It's going to store the hardware. And I'm going to put a breakpoint here. I think we should get to it anyway. Main controller. In fact, I'll put a breakpoint down here. So we're done with initialize. We're back in the YoshiStat app. So then the Meadow stack is going to call run for us. So main controller run is going to call initialize. We're going to create our display service, which creates the screen. Come down to our layouts. It's going to create the home layout, the label. It's going to put the label here and put the layout onto the screen. And so that runs through the entire app. So the challenge that I'm running into now is the display gets created and pops up, but it's not getting updated. In fact, it's over on a different monitor, so I can't show it to you because it's not draggable, because it's not interactable. And the reason for that is the way Windows works. You probably are aware that you can only affect the UI from the UI thread. And what we have is basically the UI thread is being blocked by our application. So what we need to do is we need to modify this just a little bit. Instead of just calling main controller run. Now main controller. So this is a Silk display. Silk is the driver that is giving us our windowing. So we need to be able to call this. So what I want is I want main controller to basically not be running in the context of run. I want it to be running in a background context. So let's go over to the main controller run. And we're going to make this a task. So we're going to call initialize. And remember how I had said that this is going to have some sort of a state machine that is looking at our inputs, updating our outputs. That's actually what this right here is. We're going to not tight loop. 1000 is probably faster than it needs to be. Remember, most of this is going to be event-based, user touches, things like that. If you're familiar with how Windows works, especially in WinForms, there's a message pump. This is sort of like that. We're going to just leave it like this, not worry too much about it. So just remember that if we're running a desktop application and it has a UI, we need to do this. So now if I run this app, it's going to run and our UI comes up. It's over on another screen. Let me drag it over. You can see we have our display. So we've got our label that is sitting on that layout. This is our home screen. So we have built the scaffolding for the application, at least for a desktop app. We've got some interfaces. Next time, we will look at migrating this over to the device just to make sure that the scaffolding works all there. And then we can come back and continue development on the desktop. But for now, I think this is a good stopping point. I will take all of this code, check it into the repo. I'll put that down in the comments down below. Otherwise, that's it for today. Hopefully you find this interesting and useful. If you've got any comments, questions, suggestions, by all means, leave them for us. Otherwise, we'll see you next time.